All right, let's talk about something you probably do all the time without even thinking about it, using digital photo filters. We're going to pull back the curtain and see how those really cool visual effects are actually hiding some super simple and honestly elegant logic. Let's get right into it.
You know the feeling, right? You're scrolling through your photos, you tap one little button for a filter, and boom, your picture just totally transforms. Maybe you're adding a blur or making an edge pop. It feels like magic. How does that complex change happen in literally a split second?
Well, here's the secret. It's not magic at all. It's math. And not even complicated math. We're talking about incredibly simple, surprisingly elegant math. And that's the big idea we're going to unpack today. How a few simple numbers can create something so visually complex. Okay, so to really get how this works, we need to look at the main tool in the magician's toolkit. But it's not a magic wand, it's something called a filter, or sometimes a kernel.
So, think of an image filter, this kernel, as just a tiny little pixel recipe. Seriously, that's all it is. It's a small grid of numbers that slides across every single pixel in your photo. And as it goes, it uses that recipe to cook up a new value for each pixel, based on the pixels right next to it.
The actual process is really straightforward. First, you take this little grid and you center it right over a pixel. Then, you just multiply each number in your filter grid with the image pixel's value right underneath it. You add up all those products, and that final number, that becomes the brand new value for that center pixel. You just repeat that simple little dance for every single pixel in the whole image.
Now, I know that can sound a little abstract, so let's make it super concrete with an effect we've all used, the blur. How does a simple little grid of numbers actually manage to soften up a whole picture? Okay, check this out. Here is the actual recipe for a simple blur. It's what's called an averaging filter. See how it has a quarter on the top, bottom, left, and right? That means it's taking a quarter of the value from each of its 4 direct neighbors. But, and this is the cool part, look at the number in the dead center. It's a 0. That means the new pixel value is calculated by only averaging its neighbors, completely ignoring what the pixel originally was.
And here's what that little recipe gets you. On the left, you've got your sharp image. And on the right, that's the same image after our averaging filter has paid a visit to every single pixel. All the sharp edges are gone, the little details are all smoothed out, the whole thing just feels softer. That's a blur, all created by that simple bit of math.
So let's just pause on that for a second. Why does averaging a pixel's neighbors make it blurry? I mean, what's really happening to the information in that picture when we do this?
The technical answer is that it's acting as a low-pass filter. Here's a way to think about it. Imagine that sharp edges and tiny details are like high-pitched, high-frequency notes in a song. This blur filter is like turning down the treble. It lets all the smooth, low-frequency stuff, like gentle color gradients, pass right on through, but it blocks or filters out those sharp, high-frequency details. And the result? A much smoother, softer image. Now, you might be thinking, doing all those calculations for every single pixel in a high-res photo sounds like a ton of work for a computer. And you'd be right. It is. So, of course, some clever engineers figured out a shortcut.
The problem is pretty simple. Bigger filters and bigger images mean the number of calculations just explodes. And for the kind of instant gratification we expect from our photo editors, that straightforward brute force method is just way too slow.
So that leads to the big question for any programmer or computer graphics engineer. Can we get that exact same beautiful blur, but do it with way less work?
Is there a smarter way to do the math?
And the answer is a big resounding yes. It's this absolutely brilliant mathematical trick called a separable filter. It's a special kind of filter that you can literally break apart. So instead of doing one big, complex 2D operation, you get the very same result by doing 2 much simpler 1D operations. And right here, this is the big aha moment. The hard way is smacking that whole square grid onto the image at once. The smart way is to split it up. First, you do a really simple pass across the image horizontally with just a single row of numbers. Then you take that new image and do another simple pass, but this time vertically with a column of numbers. The final picture is mathematically identical, but the process to get there is just ridiculously faster. And that, right there, is the secret sauce. Separability is what makes your photo editing apps feel instant. It just massively cuts down on the number of calculations. This isn't just some small improvement. It's a fundamental trick that makes so much of modern computer graphics and real-time effects even possible. It's a huge deal.
So, let's zoom out for a second.
We've seen how a tiny little grid of numbers can totally blur a photo, and we've seen the clever math trick that lets it happen in the blink of an eye. So what's the big takeaway here?
So what have we really learned? Well, first, that these really complex-looking effects are actually born from super simple math. Second, a blur is really just a low-pass filter that smooths things out by getting rid of sharp details. And third, these separable filters are the genius shortcut that makes it all feel so fast. This stuff isn't just a party trick, it's literally the foundation of how digital imaging works today.
And it really all comes back to this one central idea. Some of the most complex, most beautiful visual effects out there often start with the simplest bits of math you can imagine.
So I'll just leave you with this thought. If this simple little grid of numbers can create a blur, what happens when you start playing with those numbers? What kind of recipes can you cook up to sharpen an image, or to detect edges, or to create those wild artistic filters you see on social media? What other incredible visual worlds are just waiting out there to be built? All from a simple grid of numbers. Thanks for joining me.